Hey guys, welcome back to our channel Get Play Soon. In this video, we are going to cover the second problem in our greedy algorithms playlist, that is lemonade change. Lemonade change is a Leetcode problem number 860. We are a lemonade shopkeepers, so every single lemonade is of 5 rupees. So when a customer comes and gives you 5 rupees, then you have to give the lemonade. If a customer comes and give you 10 rupees, then you have to give them 5 rupees change. When a customer comes and give you 20 rupees, you have to give them 15 rupees change. Now here comes the criteria. Each customer will buy only one lemonade. And the second thing is you don't have any change in the hand at first. So they'll be giving an array of the bills. Before starting with the array, before iterating, we have zero in our account. We have zero. We don't have any money. The first thing will be if it is 5, then we can get a 5 rupee coin. Then we can start transaction and giving change from the next bill. In the first bill, we don't have anything at first. And the third point is if you can give the perfect change, then return true or else return false. Now let's see how to do this. This is a greedy problem, right? So greedy problem is nothing but giving or taking optimal decision in each and every step is known as greedy, right? So when someone comes and give 5 rupees, then we can directly give lemonade. We don't have any other options. If someone comes and give us 10 rupees, then if we have 5 rupee coin with us already, then we can give 5 rupees and we can return true. If we don't have 5 rupee coin, then we have to return false. So we have two options when 10 rupees is billed. And now for 20 rupees, we have three options. So whenever a customer will pay 20 rupees bill, we need to give back change. We prioritize giving a 5 rupee and a 10 rupee, and this is the most optimal, right? So if we have both the coins, one is 10 and one is 5, you can save the other coins and give 110 and 1 5. Or else, if you don't have 10 rupees, you can search for 3 5 rupee coins, right? If you have 3 5 rupee coins, then you can give 3 5 rupees coins and you can give. Or else, then you can return false. By the way, we prioritize giving one 5 rupee and one 10 rupee as this is the most optimal choice. Okay, if you have at least one 5 rupee and one 10 rupee left with us, it can be used for next iteration, next billing purpose, right? That's why the first option is giving one 10 rupee and one 5 rupee. So let's take an example array and let's see how it goes. So the first bill is 5 rupee. So we get 5 rupee into our account and we give one lemonade. The second is again 5 rupees. So again we get one more 5 rupee coin in our account. So we'll give the lemonade. The third thing is also 5 rupee. We get 5 rupee to our account and we give the lemonade. And the fourth thing is 10 rupee. So 10 rupee is added into our account and 5 rupee coin we give it back as a change. So we have 5 rupee coin available, we give it as a change. Next we have 20 bill. When you have 20 bill, already 5 is gone. You again give one 10 rupee and one 5 rupee and 5 rupee is left. So you are able to give 15 rupee change, right? You are able to give change for all the bills, right? That's why we return true. I hope you understand the problem. Now let's see how to do this in programming. First, in the lemonade change, it's a boolean function which means it returns either true or false. Now we are taking two variables, one is 5 and one is 10. Two variables will store how many coins we have in our account. It will store the number of coins we have. So first we iterate through each and every bill. If the bill is at 5 rupees, then we take 5 rupees coin and keep it in our account, right? So we'll increment the 5 variable. So we have one 5 rupee coin now. If it is not 5 and if it is 10, if the bill is 10 at the starting and if it is 10 and if we have 5 coins, so we don't have change to give, then we return false. If not, if we have 5 rupee coin with us to give change, we will decrement 5 rupee coin value, number of coins 5, that variable will decrement and we'll take that 10 and keep it with us, right? That's why we'll increment 10. Or else, in case the bill is at 20 rupees, we have three cases here. If 5 rupees is greater than 0 and 10 rupees is greater than 0, which means if we have both 5 rupee and 10 rupee coin, we give one 5 rupee, one 10 rupee, that is equals to 15 rupees change we will give. So decrementing 5 and 10 variable. If not, if we have three 5 rupee coins, we will decrement 3 times and we give 15 rupees change. If we don't have three fives also and if we don't have one 10 and one 5, then in the worst case we return false saying I cannot give change. So I hope you understand how we did this. Now let's discuss time and space complexity. The code iterates to each and bill only once, right? Each and every bill only one time. So the time complexity is O of n, where n is the number of bills. And in this code, we are not creating any extra space. We are creating two variables, that is also it's a fixed space, right? So the space complexity is also constant, O of 1. So that's it from my side. I hope you understood the video. If you like it, please like it and share it with your friends. Subscribe to our channel. Get blessed soon. Thank you so much for watching till the end.